Hello everybody, final exam review. Okay, make sure you have your unit circle. You are going to need it many times throughout this review. Okay, so we're starting with finding the exact value. So if you notice this is a negative angle, we're going to make it positive by adding 2 pi. 2 pi in sixths is 12 pi over 6. Why? Because 12 divided by 6 is 2. So what I'm saying is, on my unit circle, if I have, say, this point, that would be the same as, instead of just going up to that point, going all the way around and going up to that point. All the way around is 2 pi. Also, if I have a negative angle, say over here, going there is the same thing as going up and going that way. So these are called coterminal angles. Negative 7 plus 12 is 5. So I'm really looking at 5 pi over 6. And if you look at your unit circle, that would be right there. The ordered pair at that point is negative square root of 3 over 2, positive 1/2. Tangent is y over x. So the y value is 1/2. The x value is negative square root of 3 over 2. When I divide fractions, I flip the bottom fraction and I multiply. Your 2's will cancel. Then I rationalize. So times by the square root of 3 over the square root of 3. So I have a final answer of negative square root of 3 over 3. Okay, for the next one, 10 pi over 3, that angle is too big. So I'm going to subtract 2 pi. And 2 pi is going to be 6 pi over 3, because 6 divided by 3 is 2. So 10 minus 6 is 4. So I am looking at the sine, which is the y value, at 4 pi over 3. So if I go to my unit circle, 4 pi over 3 is going to be down here, and the y value there is my negative square root of 3 over 2. Still going to need our unit circle just for a little bit, and then we'll bring it back out again. Solving our equation. So first we want to get our trig part by itself, and we'll do that here by subtracting 4 from each side, and 9 over 2 minus 4, if I get a common denominator, is 1/2. So I have sine of theta is 1/2. So what I'm asking you here is, on the unit circle, what are the radian measures, what are the angles where the y value is 1/2? So when is it just here and here? And that would be at pi over 6 and 5 pi over 6. Oops, sorry about that. All right, next one. So we are getting the cosine part by itself by subtracting 5. So I have cosine of theta equals negative 2. So I'm asking you, where on the unit circle is the x value negative 2? Never. It's not. No solution. Okay. You can put your unit circle away for a little bit, but you are going to need a calculator for this one, because we are going to be using our law of sines and law of cosines. So for a second, I want to review those formulas with you. So law of sines is that sine of angle A divided by side A is proportional to the angle, or sine of the angle B over side B. And it could be A's and A's, B's and B's, C's, D's, E's, F's. It really doesn't matter. Just that the angle matches with the side. So that's law of cosines. Law of sine, oh my gosh, am I serious? Okay. This is law of sines, obviously, because it has a sine in it. Okay, then cosine is that a squared is equal to b squared plus c squared minus 2 BC cosine of A. So to actually get the A, you have to square root both sides. Or if you're solving for the angle, you actually have to subtract that, divide by the negative 2BC, and then you have cosine of A, so then you have to cosine inverse that whole big fraction. And that's how you get an angle. And again, this isn't just to find side A. You could replace this with whatever side you're solving for. You'll see when we do some problems. Okay, so this is an angle, this is a side, this is a side. Yes, I wrote ass. That means that we might have another angle B on our hands. We got to check that because this is called the ambiguous case, when you have an angle and two sides. Okay, so we're going to set this up that sine of 58 over side C, so angle C with side C, and then angle B with side B. And we're going to cross multiply. So then we have the 27 times the sine of 58, it's being all shaky, is equal to 33 times the sine of B. Divide both sides by 33, and then we're going to sine inverse this fraction in the calculator. Now make sure that your calculator is on degree mode, make sure it's on degree mode. So the way that you figure out if it's in degree mode or not is if you do tangent of 45, it should equal 1, not 1.6-ish, something. It'll say if it's in radian mode. So check it, put tangent of 45, it should equal 1, and then you're ready to go. Okay, so we're going to sine inverse this whole fraction. So sine inverse of 27 times sine of 58 divided by 33. And I got that angle B is 43.9. So let's see if that makes sense. So is side B smaller than side C? Yes. 27 is smaller than 33. So is angle B at 43 smaller than 58? Yeah, perfect. That makes total sense. Okay, so let's see if there's a possible second triangle. If angle B is 43.9, then we find its supplement, which means that we subtract from 180. And that would be 136.1. Could we have that? Nope. Because this 58 that we were given at the beginning, added to this 36.1, gives us 194, which is too big to be a triangle at 180 total degrees. Okay. This one we have a side, an angle, and a side. So we don't have to worry about ambiguous case or anything crazy like that. We are finding angle B, which is quite a problem because we have B with B, but we don't have a match A with A. So I'm going to need to find side A first. And if I have my other two sides and the matching angle, I can use the law of cosines. So A squared equals B squared plus C squared minus 2BC cosine of angle A. So I'm going to put all of this over here in my calculator, and then I'm going to square root it, and that's going to give me A. So 28 squared plus 16 squared minus 2 times 28 times 16 times the cosine of 117 gives me 1,446.775. And if I square root that, I get right about 38. Now, this is making sense so far because A is the biggest side and A is an obtuse angle. So that's making sense so far. That's good. All right, now I can set up my law of sines. So sine of 117 over 38. So sine of angle A with side A. And then we're going to use angle B with side B. Okay, do your cross multiplication again. You have sine of B times 38 equals sine of 117 times 28. Divide both sides by your 38, and then you have to sine inverse this fraction over here because you're finding an angle. So you need the sine inverse, which is the sign with the little -1. And you are going to put sine inverse of sine of 117 times 28 and divide that by 38, and it comes out that angle B is 41. And of course, since we were doing this law of sines and solving for an angle, we always want to check for a possible other angle B. But again, when we find the supplement here, 180 minus 41 is 139. And 139 would be too big to be with this 117 to actually make a triangle. So my only answer is going to be 41 degrees. Okay, let's see. We're solving for a side. Let's see if we can do law of sines. If not, we've got to do law of cosines. So we have B and B, but A and C. So yeah, that's not going to work. But we do have A and B, the angles, so we can definitely find the measure of angle C by subtraction. So if we take our 180 and subtract the 64 and subtract the 86, we get that angle C is 30. Now I have my pair, C and C, B and B. So sine of 30 over 5 equals sine of 64 over B. Cross multiply, and since I'm not inversing, I don't have to check for a second side or anything. Okay. So we have 5 times the sine of 64, and we're dividing that by the sine of 30. Oops. And that ends up being, did I do that wrong? Okay, hold on. Let me try that again. 5 times sine of 64 divided by sine of 30. 8.98. 79. Oh gosh. So right about 9. Does it say how to round on this? Oh well. Alright, last one here. Measure of angle C is 106, B is 21, A is 9, find C. I'm going to have to do my law of cosines on this one because I don't have a match. I have C and C, but I don't have any other angles to work with. So I have C squared equals B squared plus A squared, or A squared plus B squared, really doesn't matter, minus 2 times the sides times your cosine of 106. So put that into the calculator, 21 squared plus 9 squared minus 2 times 21 times 9, and then cosine of that 106. That gives you a C squared of 620, looks like a B, 626.19. So when I square root that, I get 25. So you might be wondering, isn't this ASS2? It actually isn't because it is SAS. Looks like AS, but it's actually SAS. Because if you draw a triangle, and this is A, this is B, this is C, you know angle C, you know side B, which is this one, and you know side A, which is this one. So you actually have side angle side here, and that's why we're using law of cosines rather than law of sines. This is called the included angle. Okay, see you in the next video.